Remember little Miss Muffet eating her curds and whey? Did you know that she was actually eating something like cottage cheese? Cheese was one of the first manufactured foods, and the method for making it was probably discovered about 3,500 years ago by accident. All cheese starts out as milk. When certain bacteria or fungus is added, the milk forms into a soft curd and its flavor changes. This is called curing. Then rennet, an enzyme from the stomach of a calf or sheep, is added to make the milk into a firm curd. The curd is cut and the water, or whey, is drained. Then the curd is salted and the last of the whey is pressed out. The curd is put into molds and cured some more. And what comes out is hard or soft, sweet or smelly, cheese. You can make cottage cheese in your own kitchen. You'll need to use the stove, so it's best to have an adult around to help. First of all, you'll need a pint of buttermilk, a pan, and some cheesecloth. Now click on the numbers and follow along. Heat the buttermilk slowly in the pan until the whey rises to the top. It'll look like milky water. Carefully pour off the whey. What's left is the curd. Wrap the curd in cheesecloth and let it drip in the sink or over a bowl for about 6 hours. Put the curd in a bowl and break it up into small pieces. Now add salt if you like and put the bowl in the refrigerator. Wait until it's cold. That's it. You now have cottage cheese for you and your friends. If you wanted to sample every cheese made in the world today at the rate of 1 variety each day, it would take you more than 5 years. That's because there are over 2,000 varieties of cheese made around the globe. But all of them come from just 3 main types of cheese: hard cheeses like cheddar, soft ones like cream cheese, and blue cheeses like Roquefort. Some countries are famous for their cheeses. Brie is a well-known cheese from France. Parmesan is a cheese made in Italy. The United States is known for its American cheese, of course, but also for some of its cheddar. The U.S. produces more than 1 million tons of cheese each year, most of it from Wisconsin. Do you know where your favorite cheese comes from? Click on a country to find out what kind of cheeses are made there. Do you sprinkle Parmesan or Romano cheese on your spaghetti? If so, you're using an Italian cheese. The Swiss are particularly fond of their Emmentaler and Gruyere cheeses. In France, they often eat Camembert and Brie for dessert. Edam and Gouda are delicious cheeses from Holland. From England, we get famous hard cheeses like Cheddar and Stilton. It's no surprise that American cheese is made in the United States, but did you know that some famous cheddar is too? When we think of the tiny living creatures known as bacteria, we usually think of infection and disease. But some bacteria is actually useful. In fact, bacteria is used to give Swiss cheese its holes and its sweet nutty flavor. Harmless bacteria and molds are allowed to grow on cheese while it's held in storage under controlled conditions. This is called curing. In Swiss cheese, bacteria grows and gives off gases. These gases form the round holes or eyes that make Swiss cheese so familiar. By the way, bacteria and molds are also used in other cheeses. For instance, a mold in blue cheese gives it a bluish color and a very strong flavor. All cheese starts from milk, but you'd be surprised at all the different kinds of milk people use. Click on the map to find out how cheese is made in other countries. In many parts of Asia, sheep's milk is the main ingredient in cheese. In Mongolia, camel's milk is the base for cheese. There are lots of reindeer in the Arctic, right? So they make their cheese out of reindeer milk. Most cheese in the United States comes from cow's milk. The ancient Greeks often used horse's milk for cheese. Today, Greeks prefer to use goat's milk.
step into the rings with me. Why should you come inside? Because it's there. Take one small step inside to find out more about life on the moon. I got squared away when I made short stuff of that French guy. Can you imagine building Egypt's pyramids with no cranes, forklifts, or trucks, with little more than your bare hands? Some of these enormous stone tombs are almost 500 feet high. In the Great Pyramid at Giza, for example, there are over 2,300,000 blocks of stone. Each block is as big as a large room in a house. The largest are 7 feet high and 18 feet across. It's said that 100,000 slaves labored for 20 years to build the Great Pyramid. Each of the 2-ton blocks of limestone or granite was brought by boat across the Nile River and pulled on sledges along a road from the docks to the building site. Now, as the pyramid grew higher, slaves pulled the stone blocks up ramps to the top. The inside blocks were left rough, but the outside ones were very smooth and even, and the pyramids were so well constructed that you can still see them today if you ever visit Egypt. The pyramids were designed for a special purpose: to preserve the bodies of Egyptian kings or pharaohs. The Egyptians believed in life after death. They thought that their future life depended on keeping the body well preserved. So pharaohs' bodies were mummified and hidden in special rooms below ground in a pyramid. Food and other necessities of life were buried with them. The pyramids were designed with many rooms and false passages in order to confuse would-be grave robbers. Archaeologists think the pyramids were built around 2500 BC. We know for sure that the Great Pyramid at Giza was built by the pharaoh Cheops somewhere around that time. And the Egyptians weren't the only culture to have pyramids. They were also built by people as close as Greece and as far away as Mexico. The ancient structure at Stonehenge is one of the world's great mysteries. What are these massive rocks perfectly aligned to the heavens? Stonehenge, which stands near Amesbury in England, is a structure of upright stones and ditches placed in a circle. The stones are set in 2 circles and 2 horseshoes of upright stones. Some of the separate stones have been given fanciful names, such as the altar stone and the slaughter stone. Some of them feature primitive engravings, such as these daggers and axes. Cremated human bones have been found in pits located around the structure. Legend has it that the stones were magically transported from Ireland by Merlin the magician. But today, scientists know that parts of Stonehenge date back to about 2800 BC. Most now think that Stonehenge was built by the Stone Age and Bronze Age farmers and herdsmen of southern England. It's true that no one knows why Stonehenge was built, although people have been fascinated by it for a long time, and they have come up with several theories. For example, it's known that parts of Stonehenge are aligned so that the midsummer sun rises at a particular point. Some people also noticed that the positions of the stone blocks can be used to measure the movement of the sun and moon and are aligned with eclipses. So they theorized that Stonehenge might be some sort of solar calendar. But what about the cremated bodies in the pits? Was it a religious site or perhaps a graveyard? Most people think that Stonehenge was a sacred enclosure, combining religious, scientific, and social aspects of life in prehistoric Britain. But beyond that, we may never discover the meaning behind the mystery of Stonehenge. Imagine yourself roller skating down the sidewalk or soaking in a hot bath, when suddenly everything stops and freezes, like in a photograph. That's just what happened to the city of Pompeii. On August 24, 79 AD, the southern Italian volcano Vesuvius erupted. covering Pompeii with ashes 18 to 20 feet deep. When water came down on the ashes, the material became like clay, leaving everything exactly as it was before the eruption. Pompeii was forgotten until 1763, when excavation started. Over the years, archaeologists have found remains of entire families going about their daily lives and ovens with loaves of bread still in them. The houses, roads, and theaters, everything is just as it was. By exploring the ruins of Pompeii, archaeologists have been able to arrive at an accurate picture of life almost 2,000 years ago. Did you know that when it's 12 noon in Paris, it's only 3 a.m. in Los Angeles? Well, that's because Paris and Los Angeles are in different time zones. Time zones are based on lines of longitude. As you move east from Greenwich, England, you add 1 hour for every line of longitude. As you move west, you subtract 1 hour. So when it's 12 noon in Greenwich, it's 7 a.m. in New York, 5 lines of longitude away. Time zones aren't set in straight lines, however. That's because individual states and countries choose which time zone they use. On the opposite side of the world from Greenwich is the International Date Line. Cross it going west and you lose a day. Cross it going east and you gain a day. So if you were at the International Date Line on your birthday, you could celebrate one day, cross the line, and celebrate again. Now take a look at this map. By clicking on a city, you can find out what time it is there when it's noon in New York. It's 9 a.m. in Los Angeles, surf's up. It's 11 a.m. in sunny Guatemala. It's noon in the Big Apple, New York City. It's 2 p.m. in Buenos Aires, time for a siesta. It's 5 p.m. in foggy London. We say 6 p.m. in Paris. It's 7 p.m. in Greece. Pass the feta cheese, please. It's 8 p.m. in Moscow, comrade. It's 10:30 p.m. in India. Pass the puri, please. It's 1 a.m. in Hong Kong. Time for a rickshaw ride home. It's 2 a.m. in Japan. Do you have a yen to go to sleep? It's 3 a.m. in Sydney, Australia. Good morning, mate. Meanwhile, in New Zealand, it's a sleepy 5 a.m. When one mountain climber was asked why he wanted to risk his life to conquer Mount Everest, his often quoted reply was, "Because it's there." And at 29,028 feet, Mount Everest is the highest mountain in the world, taller than 20 Empire State Buildings piled on top of each other. Sir Edmund Hillary and Tenzing Norgay traveled to the Nepal-Tibet border in 1953 and became the first to conquer Mount Everest. But mountains rise not only from land areas, but also from the bottom of the sea. If you consider the total height of a mountain to include what's under the sea, then Mauna Kea in Hawaii is the highest. It rises 13,796 feet above sea level, but its base is about 16,000 feet below the water. So at 30 to 32,000 feet total, it's even taller than Mount Everest. But Mount Everest holds the title because it's the tallest mountain that can be climbed from base to summit. Would you like to know more? Just click on the map to find out mountains in some other countries. Mount McKinley in Alaska tops off at 20,320 feet. Mauna Kea in Hawaii would be the highest mountain in the world, except that the first 16,000 feet are below water. Above sea level, it rises 13,796 feet. Mount Aconcagua on the Argentine-Chile border is a towering 22,835 feet tall. The tip of Mont Blanc in France is 15,771 feet tall. Mount Kazbek in the Soviet Union rises to 16,540 feet. Mount Kilimanjaro in Africa gets up to 19,565 feet. Mount Goodwin-Austen, also known as K2, rises to a majestic 28,250 feet. Mount Everest on the Nepal-Tibet border is the granddaddy of the big mountains at 29,028 feet. Mount Kosciuszko is the tallest mountain in Australia at 7,305 feet. Mount Markham in the frozen Antarctic is a snowy 14,270 feet high. Imagine a whirling tower of wind so powerful that it can snatch up cars and carry them for miles. How do tornadoes, those destructive wind demons of nature, get started? Well, a tornado is a special kind of storm where winds circle round and round toward the center of an area of low pressure. A tornado begins with rising air and winds that blow in opposite directions. Now this starts a violent spiraling effect. Then, centrifugal force throws the air away from the center, leaving a narrow core of low pressure in the middle. This low-pressure core acts like a powerful vacuum on everything it passes. Winds up to 300 miles an hour can collapse walls of houses and destroy everything in their path. Most people who live in tornado areas take refuge from the storm in underground storm cellars that keep them safe until the storm passes. Tornadoes are sometimes called cyclones or twisters, and you can actually see the twisting column of air and dust from miles away. In the U.S., tornadoes occur most frequently in the central states, where they travel in a northeasterly direction at 20 to 40 miles an hour. Fortunately, they usually travel for only a few miles and have a fairly narrow path. Even so, tornadoes cause a lot of damage wherever they touch down. Entire towns have been destroyed by big ones. Oh, by the way, in the northern hemisphere, most tornadoes spin counterclockwise. And in the southern hemisphere, they usually travel clockwise. If you've ever felt an earthquake, you know that the trembling or vibration of the Earth's surface can be a pretty scary experience. Earthquakes occur because there is continual sliding and breaking of the brittle crust at the surface of the Earth. A place where two sections of crust move against each other is called a fault line. Sometimes the sides move up and down, and sometimes they move lengthwise. This movement produces an enormous amount of energy, which is changed into vibrations in the rocks, and we feel it as an earthquake. The vibrations may travel for thousands of miles through the Earth, sometimes splitting it with long, deep cracks. Some earthquakes cause a tremendous amount of damage, while others feel no worse than a short roller coaster ride. Large earthquakes are often followed by aftershocks, quakes caused by the first trembler that can come minutes, days, or even years afterwards. Scientists measure the intensity of an earthquake with an instrument called a seismograph. There are two scales of measurement that are used to figure out how strong the quake was. One scale is called the Mercalli scale, and it goes from a small quake, a number 1, to the largest at number 12. The Richter scale, named after its inventor, Charles Richter, measures quakes on a scale that starts at 1 and goes on forever. But every whole number on the Richter scale is 10 times higher than the number before. So a 2-point earthquake is 10 times stronger than a 1-point. And a 4-point quake is 1,000 times stronger than a 1-point. An earthquake that measures 6 or over on the Richter scale is considered dangerous. Have you ever heard someone say that he was in the eye of a storm? Well, it means he's in the center of all the action, just as the eye of a hurricane is in the center of that fierce tropical storm. But the eye of a hurricane is still and calm, not violent at all. It's the rest of the hurricane that's so ferocious. A hurricane is a huge storm, 25 to 600 miles wide, with winds up to 200 miles an hour and driving rain. The eye of a hurricane is a small area of very low pressure in the center of the column of spiraling wind. The eye is usually about 10 to 20 miles wide, and in the eye, the sky may be blue and there may be only a light breeze. If you were in the eye of a hurricane, you might think the storm was over, until the winds began to blow again from the opposite direction. Has anyone ever said you were in the doldrums when you were acting tired or sad? Well, there really are places called the doldrums, and they're where many hurricanes start. The doldrums are areas in the Atlantic and Pacific Oceans near the equator. They're called the doldrums because air is always blowing upwards in this region, and early sailors were unable to sail in the listless winds. Hurricanes begin when the moist air near the water rises and is replaced by cooler, thicker air which blows inward in a spiral. By the way, hurricane is the name people give to these storms when they start in the Atlantic or Eastern Pacific regions. The word comes from the West Indian word huracan, which means big wind. But if the same kind of storm starts in the Western Pacific area, it's called a typhoon, from the Chinese word typhon, which is just another way of saying big wind. In 1980, the American volcano Mount St. Helens erupted for the first time in 123 years. It blew out an entire side of the mountain and spread black ash into towns 85 miles away. Volcanoes form because the temperature under the surface of the Earth gets hotter as you go deeper. At a depth of about 20 miles, it's hot enough to melt most rocks. As rock melts, it expands. This liquid rock, called magma, forms into reservoirs under mountains. The magma rises up through the cracks in the earth, and when the pressure becomes too great for the surface rock to bear, it bursts through as a volcano. The crater, the deep hole in the middle of the volcano, is where the opening reaches the surface and the magma spews out. Temperature and pressure at the surface change the magma into lava. Rivers of lava have been known to bury entire cities. Most people think that planets are discovered by accident, but scientists actually went looking for Neptune and Pluto, and they were pretty sure where they'd be. You see, we know that planets are pulled, not just by the sun's gravity, but by the gravitational pull of other nearby planets. Armed with this knowledge, two scientists in 1846 saw that there was something peculiar about the orbit of Uranus. At that time, Uranus was the outermost known planet, but its orbit indicated that it was being pulled by something even farther away. So they figured out where the unknown planet should be, and sure enough, there was Neptune. But the orbit still looked odd, and Neptune's orbit wasn't quite right either. People started searching for yet another distant planet, and in 1930, Pluto was discovered. Today, some scientists think there may even be a planet beyond Pluto, which for now they're calling Planet X. There are two scientific laws that helped people figure out that there were more planets past Uranus. These laws are Kepler's law of planetary motion and Newton's law of gravity. Kepler's law of planetary motion says that planets' orbits around the Sun are not perfect circles. Newton's law of gravity explains that two objects attract each other depending on the amount of mass in each object. Mass is how much matter each object has in it. Attraction also depends on how far apart the objects are. The greater the mass, the stronger the pull, and the closer together they are, the stronger the pull. Using these laws, scientists recognized that there had to be something of great mass pulling at the orbit of Uranus. And of course, that mass was the planet Neptune. Since the beginning of time, legends have been passed along about life on the moon, from Roman gods to the man in the moon. But long before the moon was explored, scientists realized we wouldn't find any life there. This is how they figured it out. The moon has no twilight. 1 minute it's light, and the next minute it's dark. Here on Earth, we do have twilight. Twilight is created as our atmosphere reflects the sun's rays even after the sun is set. So because the moon has no twilight, scientists knew that there was no atmosphere on the moon. Nothing to protect it from the sun's harmful radiation and heat. Nothing could live in that kind of environment. During a moon day, which lasts a full 2 weeks, temperatures soar to 300 degrees Fahrenheit. And at night, which also lasts for 2 weeks, temperatures can get down to 260 degrees below zero. On July 21, 1969, 2 American astronauts, bundled in heavy spacesuits and moon boots, took the first steps on the surface of the moon. From their orbiting Apollo 11 spacecraft, they flew down to the lunar surface in a landing module called the Eagle. The world watched as Neil Armstrong slowly climbed down and planted his feet on the dust and rocks of the moon. These were his words at that historic moment.
It's one small step for man, one giant leap for mankind.
It had taken 8 years and $25 billion to achieve this lunar landing, and it was cheered on by the millions of people around the world glued to their televisions. Minutes later, Edwin Aldrin Jr. joined Armstrong on the moon. The astronauts returned with moon rocks and soil samples, and the one thing that we had waited for eons, a first-person look at the moon. Light travels faster than anything we know, but a Danish astronomer was able to figure out its speed over 300 years ago with little help from Jupiter. Back in 1676, Olaus Remmer was watching as one of the moons of Jupiter passed behind the planet, became eclipsed, and reappeared on the other side. Remmer recorded these eclipses as they occurred over and over. He noticed that the length of time between these eclipses got shorter as Jupiter and Earth moved closer together, and then longer as the Earth moved away again. There was about 17 minutes difference. Well, Remmer realized that when the 2 planets were far apart, the eclipse's light took longer to get to Earth. That meant that the distance the light traveled was what actually made the eclipses seem early or late. Using the 17-minute time difference and the known distance between Earth and Jupiter, he came up with a rough figure for the speed of light. Olaus Remmer calculated that light must travel at about 135,000 miles per second. In the early 1900s, Professor Albert Michelson determined a more exact speed of light, 186,282 miles per second. So Remmer's calculations were somewhat off, yet it's still remarkable that he came so close without using any modern tools or instruments. But what does the speed of light mean to us? Well, the Sun is 93 million miles from Earth. That's about 8 light minutes away. Now, this means that the light you see right now was sent from the Sun 8 minutes ago and has been traveling through space on its way to Earth for 8 minutes. And perhaps you've heard the term light year. Well, light year is actually a measurement of distance, not of time. If you take the light speed of 186,000 miles per second and multiply it by the number of seconds in a year, we find that light travels 5,880,000,000,000 miles in a year. That distance is a light year. Saturn is probably the easiest planet to recognize because it's surrounded by those colorful rings. In 1610, when Galileo first noticed Saturn's rings, he thought they were 2 fuzzy moons. Then, in 1655, Christian Huygens studied Saturn with a better telescope and saw the rings more clearly. There have been many theories about the rings of Saturn, but not until the spacecraft Voyager 1 sent back pictures in 1980 did we realize how complex they really are. The rings seem to have 7 major divisions and hundreds of thousands of subdivisions, well, like the grooves on a record. They're made mostly of ice in all sizes, from chunks and boulders down to tiny chips, all herded closely together in a narrow band that's less than 1 kilometer wide. Scientists think the rings may be the remains of a moon that exploded, or possibly interplanetary matter that drifted into Saturn's gravitational pull. It's often true that the more we learn about Saturn and the other planets, the more questions we have. For instance, Voyager 1 showed us close views of Saturn that man had never seen before. But now these pictures have got us wondering. One strange phenomenon seen in the Voyager photos were dark, fast-moving spokes in Saturn's rings, changing shape, then disappearing, as if the rings were a great spinning wagon wheel. Another odd thing was a narrow ring that looked for a while as if it were 3 or 4 ringlets braided together. These two curious effects are still mysteries, but perhaps one day you'll be the one to solve them. Ever since astronomers noticed a network of what looked like canals crisscrossing Mars, many people have imagined an advanced civilization living on Mars. But when Viking 1 landed on Mars in 1976, it was determined that the canals were only optical illusions. Instead of a Martian civilization, we saw photos of a windswept, rock-strewn, reddish desert. Even the sky was red because of the iron particles in the very thin atmosphere. The atmosphere is nearly 100 times thinner than Earth's, and it's mostly carbon dioxide. We Earthlings certainly couldn't live in that atmosphere, and neither could any other similar form of life. We also learned that Mars has polar ice caps and definite seasons, as Earth does. There's no liquid water on Mars, again because the atmosphere is too thin, and it gets terribly cold there, from a high of 0 degrees during the day down to 150 below at night. Even though Mars is about half the size of Earth, a Martian day is just 37 minutes longer than our Earth day because it rotates more slowly. But a Martian year, the time it takes Mars to orbit the Sun, is almost twice an Earth year. 1 year on Mars is 669 Earth days. If we thought of that in our normal calendar months, each month would have about 55 days. We already know that the Martian atmosphere is thin. A jet plane flying at about 100,000 feet would be in a similar kind of atmosphere, and so would a mountain climber going straight up 20 miles. But because there's so little oxygen in the atmosphere, a person would suffocate in only 30 seconds or so. And if the atmosphere or extreme cold didn't get him, the ultraviolet rays of the sun would. Because the rays come through the very thin atmosphere, they would severely sunburn a human body in just 15 minutes.